In the autumn of 1943, a Republic P-47 Thunderbolt fighter plane lay abandoned in a French field, a silent testament to a pilot's hasty escape. Its propeller blades were visibly bent, and its landing gear had buckled under the impact, yet the formidable aircraft remained largely intact, an unexpected prize. The American pilot had ejected during a perilous low-level strafing mission, and now, this colossal 7-ton marvel of American aeronautical engineering had unexpectedly fallen into the hands of the German Luftwaffe. Within mere hours, a specialized German recovery team descended upon the crash site with the fervor and meticulousness of archaeologists unearthing an unprecedented alien artifact. While they were no strangers to the wreckage of downed Allied aircraft, having previously encountered iconic Spitfires, sleek P-38 Lightnings, and even the occasional behemoth B-17 bomber, the Thunderbolt presented an entirely different enigma. Its sheer scale was astonishing, an almost grotesque mass for a single-engine fighter, and its formidable reputation among the Luftwaffe's pilots had already begun to solidify into something akin to an enduring myth. The subsequent recovery operation itself demanded an extraordinary level of precision and care. German mechanics, exhibiting remarkable expertise, painstakingly disassembled the aircraft's primary components. These critical sections were then carefully loaded onto sturdy flatbed trucks and transported with utmost security to Rechlin, the Luftwaffe's principal testing and evaluation facility, strategically situated approximately 60 miles north of the bustling German capital of Berlin. Rechlin transcended the definition of a mere airfield. It functioned as the veritable nerve center of Germany's sophisticated aviation intelligence network, a place where captured enemy aircraft underwent the most exhaustive and rigorous analytical scrutiny. By the waning months of 1943, the facility had transformed into an almost surreal museum dedicated to the display of Allied air power, presenting a bizarre panorama where American, British, and Soviet aircraft stood in stark, silent juxtaposition with cutting-edge German prototypes, thereby creating an almost dreamlike tableau that vividly encapsulated the fiercely competing philosophies of the ongoing air war. The arrival of the P-47 at Rechlin ignited an immediate surge of excitement and intense curiosity among the facility's highly specialized technical staff and seasoned test pilots. For several months prior, they had been receiving increasingly disquieting reports from the embattled Western Front. Luftwaffe pilots consistently recounted how these American fighters, and particularly the robust Thunderbolts, possessed an uncanny ability to withstand battle damage that would unequivocally obliterate a more fragile Messerschmitt Bf-109 or a Focke-Wulf FW-190. Pilots spoke of expending entire ammunition loads into P-47s during heated aerial engagements, meticulously observing their cannon shells striking home with undeniable force, only to watch in disbelief as the American fighter continued its flight seemingly unperturbed, as if the barrage had been inconsequential. Some pilots, grappling with these perplexing observations, began to suspect that their ammunition was fundamentally defective. Others pondered whether American metallurgical advancements had somehow dramatically outpaced German capabilities. The more superstitious among them resorted to hushed whispers, suggesting that the Americans had perhaps developed some form of advanced, impenetrable force field technology. German intelligence officers were in urgent need of concrete answers. The relentless and resource-intensive Eastern Front was consuming military assets at an astronomical and unsustainable rate, and the Luftwaffe simply could not afford the egregious waste of precious ammunition on aircraft that appeared to possess an almost miraculous immunity to their firepower. If the P-47 truly harbored some revolutionary defensive technology, it was imperative for Germany to fully comprehend it, to replicate its design, or to develop effective countermeasures without delay. The captured Thunderbolt, in its remarkably preserved state, represented an unparalleled opportunity to definitively resolve this pressing mystery through direct, empirical examination, rather than relying on the often unreliable and speculative reports emanating from the chaos of the battlefield. What rendered this particular aircraft exceptionally valuable was its remarkably good condition. Unlike the majority of captured planes, which typically arrived as twisted, unrecognizable wreckage necessitating extensive and costly reconstruction efforts, this P-47 required only relatively minor repairs to render it airworthy once more. The powerful engine remained miraculously intact, the robust airframe exhibited no significant structural damage, and the vast majority of its intricate internal systems appeared to be fully functional. German mechanics, brimming with optimism, conservatively estimated that they could have the aircraft flying within a matter of weeks. Crucially, its pristine state meant they could subject it to the kind of rigorous, destructive testing that would unequivocally reveal the precise reasons why these formidable aircraft consistently survived combat damage that, by all conventional understanding, should have proven unequivocally fatal. The stage was thus meticulously set for what promised to be one of the most profoundly revealing and impactful aircraft evaluations of the entire war. The P-47 Thunderbolt was never conceived with aesthetic beauty as its primary design objective, and it certainly was not engineered with lightness in mind. When Republic Aviation's visionary design team convened in 1940 to conceptualize a fighter aircraft built around the colossal Pratt & Whitney R2800 double Wasp engine, they made a deliberate and pivotal decision that would fundamentally shape every subsequent aspect of the aircraft's development. Paramount survivability would unequivocally take precedence over any considerations of elegant design or aerodynamic finesse. The R2800 engine was, by all accounts, an absolute powerhouse, an 18-cylinder radial engine capable of generating an astounding 2,000 horsepower, a figure later incrementally boosted to an even more formidable 2,500 horsepower in certain advanced variants. To provide a clearer comparative perspective, the contemporary Bf-109G typically produced approximately 1,475 horsepower, and even the robust FW-190A, renowned for its power, only managed to peak at around 1,700 horsepower. The Thunderbolt, therefore, possessed a raw, unadulterated power output that German fighter aircraft simply could not hope to rival. However, such immense power was not without its inherent trade-offs and consequences. The P-47D, which emerged as the most ubiquitous and widely deployed variant, weighed approximately 10,000 pounds when empty, and could astonishingly reach a staggering 17,500 pounds when fully laden with fuel, ammunition, and various ordnance. This made it roughly twice as heavy as a standard Bf-109. German engineers, meticulously examining the intricacies of the captured aircraft, expressed profound disbelief that a single-engine fighter could possibly be so extraordinarily heavy, and yet still operate with such remarkable effectiveness. Their own deeply ingrained design philosophy staunchly emphasized lightweight and exceptional agility, prioritizing the ability to decisively outturn an adversary in the close quarters, high-stakes ballet of a dogfight. The Americans, it appeared, had adopted an almost diametrically opposed strategy, opting instead to construct what was, in essence, a flying tank. Please stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. The Thunderbolt's imposing size was partly a direct consequence of its sophisticated turbocharger system. In stark contrast to German fighters, which typically employed mechanically driven superchargers mounted directly onto the engine block, the P-47 utilized a massive General Electric turbocharger strategically positioned in the aircraft's rear fuselage. Hot exhaust gases, expelled from the powerful engine, were ingeniously channeled to spin a turbine, which in turn drove a compressor. This compressor then forcibly inducted and pressurized air into the engine, particularly crucial at high altitudes, where the thin atmosphere would otherwise severely starve the engine of vital oxygen. This intricate system necessitated an extensive network of ducting pipes that traversed the entire length of the fuselage, efficiently conveying superheated exhaust gases rearward and compressed air forward. While the engineering was undeniably complex, inherently heavy, and somewhat susceptible to leaks, it endowed the Thunderbolt with truly phenomenal high-altitude performance capabilities. At an altitude of 30,000 feet, where the Bf-109s and FW-190s struggled to breathe and experienced significant power degradation, the P-47 continued to produce its maximum horsepower with unwavering efficiency. The fuselage itself was constructed with the resilience of a veritable fortress. Republic's astute engineers had meticulously analyzed combat damage reports gleaned from early war fighters and had definitively concluded that the vast majority of fatal hits occurred in remarkably predictable locations, specifically the engine, the cockpit, and the critical fuel system. Consequently, they comprehensively armored every single one of these vulnerable areas. The pilot was ensconced behind a formidable quarter-inch steel plate integrated into his seat back, and was further protected by robust bulletproof glass positioned directly in front. Additional layers of armor safeguarded the engine from dangerous frontal attacks. The fuel tanks themselves incorporated a revolutionary self-sealing design, featuring multiple resilient layers of rubber that would ingeniously swell and effectively close bullet holes upon exposure to fuel. While this groundbreaking technology had existed in British aircraft, the Americans had refined it to an exceptionally advanced degree. Furthermore, an astonishing degree of sheer redundancy was meticulously engineered into every critical system. The P-47 boasted multiple, independently functioning fuel pumps, sophisticated backup electrical systems, and control cables that were deliberately routed through disparate sections of the airframe, ensuring that a single, unfortunate cannon hit could not simultaneously sever them all. The intricate cooling system for that colossal engine was intelligently distributed across a significantly large area, meaning that localized damage would not precipitate immediate or catastrophic overheating. German fighters, designed with an unwavering emphasis on minimum weight and maximum performance, possessed no such luxurious redundancy. A single precisely aimed 20mm shell in the right vulnerable spot could cripple a Bf-109's cooling system, compelling the pilot to shut down the engine within minutes, or risk an inevitable and catastrophic engine failure. The German technicians at Rechlin, despite their initial astonishment, grasped the fundamental specifications of the captured P-47 even before commencing their detailed evaluation. However, merely understanding numbers on paper and experiencing the formidable aircraft firsthand were two entirely distinct and incomparable propositions. Rechlin was not in the business of simply assigning random pilots to captured aircraft. The Luftwaffe maintained a highly specialized unit known as Circus Rosarius, named after its esteemed commander, Theodore Rosarius, which was specifically tasked with the critical mission of evaluating enemy equipment. By 1943, this elite unit had evolved into one of the most formidable and respected groups within the entire Luftwaffe, staffed exclusively by battle-hardened combat veterans who possessed not only the exceptional skill to fly, but also the profound ability to meticulously analyze an aircraft's intrinsic strengths and weaknesses from a highly informed operational perspective. These were not mere test pilots in the peacetime sense of the word. They were seasoned warriors, who had miraculously survived hundreds of arduous combat missions and could, with unerring instinct, immediately discern whether a particular design feature would genuinely matter in the crucible of actual battle. Hermann Graf, a legendary ace, was among the select few chosen for the prestigious P-47 evaluation. By the close of 1943, Graf had amassed an astonishing record of over 200 confirmed aerial victories on the brutal Eastern Front, cementing his status as one of Germany's most successful and revered fighter pilots. He had flown virtually every type of fighter, from the early Bf-109E models to the very latest FW-190A8s, endowing him with an encyclopedic and nuanced understanding of fighter aircraft handling characteristics and combat performance. The Luftwaffe specifically sought pilots of Graf's caliber because they would remain unimpressed by mere novelty and utterly unintimidated by foreign technology. They would approach the evaluation of the Thunderbolt with the same cold, methodical, and objective scrutiny they applied to assessing a potential opponent in combat, relentlessly searching for any exploitable vulnerabilities. Alongside Graf, several other highly experienced and decorated pilots rotated through Rechlin for the comprehensive evaluation. Hans Werner Lurk, another distinguished pilot, dedicated considerable time to scrutinizing captured Allied aircraft, and would later extensively document his invaluable experiences and insights. These exceptional men fully understood that their meticulously detailed reports possessed the potential to profoundly influence Luftwaffe tactics across the entire Western Front. If they were to discover a critical weakness in the P-47, perhaps an inability to turn tightly at low speeds, or significant blind spots within the cockpit, that crucial intelligence would be swiftly disseminated to fighter squadrons within a matter of days. Conversely, if their findings unequivocally confirmed that the Thunderbolt was indeed as incredibly tough and resilient as frontline pilots vehemently claimed, the Luftwaffe would be compelled to fundamentally adjust its entire approach to engaging the formidable American fighter escorts. The comprehensive assessment of American fighter escorts was a critical undertaking. The evaluation process at the Rechlin facility adhered to a rigorously structured protocol. Initially, aviators would meticulously scrutinize the aircraft through walk-around inspections, examining its fundamental construction, integrated armament, and complex operational systems. They would then delve deeply into the cockpit layout, diligently noting the precise placement of critical controls by American designers, and critically comparing the scope of visibility to that offered by their own German fighters. Following this, static ground engine runs were performed to ascertain the power plant's intrinsic characteristics and operational nuances. Only subsequent to this exhaustive preliminary assessment would the pilots embark upon actual flight testing. Even this aerial examination followed a careful, progressive sequence, commencing with brief hops around the immediate airfield, then gradually expanding the scope to encompass demanding aerobatic testing, perilous high-speed dives, and intricate simulated combat maneuvers, all designed to push the aircraft to its theoretical and practical limits. This entire investigative operation was documented with an almost obsessive degree of thoroughness. German technicians meticulously photographed every minute detail, precisely recorded countless measurements, and diligently compiled exhaustive technical reports. These comprehensive findings were subsequently distributed to both national aircraft manufacturers and the High Command of the Luftwaffe. Their objective extended far beyond merely comprehending the intricacies of a single captured P-47 Thunderbolt. Rather, they aimed to unravel the entire American design philosophy, seeking to understand its fundamental tenets. Crucially, they sought to determine what valuable lessons German engineers could extract from this formidable aircraft, whether there were particular features or innovative solutions worth emulating, and, perhaps most importantly, if any inherent flaws could be strategically exploited in future combat scenarios against Allied forces. Beyond the purely technical aspects, these evaluations also contained a significant element of psychological warfare. The Luftwaffe, on occasion, would strategically deploy captured enemy aircraft in active combat, having first repainted them with distinctive German markings. These remarked machines were then flown directly against Allied formations in an attempt to sow widespread confusion and disorientation. Imagine a P-47, emblazoned with Luftwaffe insignia, unexpectedly appearing in a critical sector at a crucial moment. Such a sight could easily induce a momentary but perilous hesitation among American pilots. In the unforgiving crucible of aerial combat, even the briefest moment of indecision was frequently fatal. However, this deceptive tactic could only prove effective if German pilots had thoroughly mastered the operational characteristics of the captured aircraft, enabling them to fly it convincingly enough to be mistaken for an American pilot, at least when viewed from a distance. As the dedicated Reckland team meticulously prepared for their inaugural flights in the formidable Thunderbolt, they carried with them not only the invaluable collective experience gleaned from hundreds of previous air battles, but also a profound, burning curiosity regarding whether this impressively massive American fighter could genuinely live up to its rapidly growing and formidable reputation. Ask US to stay with US and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you're from and what you think about the video topic. Upon maneuvering himself into the P-47's cockpit, the renowned ace Hermann Graf immediately comprehended why American pilots typically needed to possess a reasonably tall stature. While the cockpit certainly did not induce a claustrophobic sensation, actually boasting a greater internal volume than the Bf-109, every control and display seemed positioned to accommodate an aviator endowed with longer legs and arms than the average German airman. The rudder pedals, for instance, were situated quite far forward. The primary control stick ascended from the floor at an unaccustomed angle, and the extensive instrument panel appeared to stretch considerably into the distance. Where German fighters were meticulously designed to envelop their pilots like custom-tailored suits, offering an intimate, almost symbiotic connection, the Thunderbolt, by stark contrast, conveyed the sensation of merely sitting within a small, albeit functional, room. The degree of visibility afforded by the Thunderbolt was nothing short of revelatory. The P-47's distinctive bubble canopy, a crucial innovation first introduced on the D model, presented an almost complete 360-degree panoramic view. This expansive perspective made the heavily framed canopy of the Bf-109 seem, by stark comparison, akin to peering out through a narrow letterbox slit. Graf found he could look directly behind himself without any physical strain, effortlessly scan the airspace both above and below with only minimal head movement, and maintained an utterly unobstructed view of both wingtips. In the ferocious crucible of aerial combat, such unparalleled situational awareness would unquestionably confer an enormous tactical advantage. Luftwaffe pilots had, through bitter and often fatal experience, learned the harsh truth that the vast majority of aerial kills originated from attacks that the victim never even perceived coming. Consequently, the P-47's superior canopy design rendered surprise attacks against it significantly more challenging to successfully execute. Initially, the intricate instrument layout proved quite baffling to the German pilots. American designers had configured everything in a fundamentally different manner. Airspeed was displayed in miles per hour rather than the familiar kilometers. Altitude was measured in feet instead of meters, and there was a bewildering, almost overwhelming, array of gauges dedicated to managing systems that German fighters simply did not possess. For instance, there were multiple selectors for the fuel tanks, necessitated by the P-47's capacity to carry fuel within its fuselage, wings, and even external drop tanks. A complex turbocharger control system, complete with its own dedicated regulators and pressure gauges, added another layer of operational intricacy. The electrical panel alone, a hub of numerous switches, contained more toggles and buttons than the entire cockpit of a Bf-109E. Consequently, it took Graf and his fellow pilots several arduous hours simply to decipher the function of each individual control and instrument, and an even more protracted period to fully memorize the precise, multi-step engine startup sequence. The armament switch panel on the P-47 immediately revealed another core American design philosophy: the deployment of overwhelming firepower. The P-47D model was formidable, carrying 8 Browning M2.50 caliber machine guns, with 4 precisely integrated into each wing, and each gun supplied with approximately 425 rounds of ammunition. This translated into an astonishing total of about 3,400 rounds available to the pilot for a single mission. By way of comparison, the FW-190A8, a contemporary German fighter, typically mounted 4 potent 20mm cannons and 2 13mm machine guns, but with a significantly smaller total ammunition load. The American approach, therefore, clearly emphasized sheer volume of fire, aiming to create such a dense, inescapable cone of bullets that evasive maneuvers by an enemy aircraft became nearly impossible. The German approach, conversely, prioritized hitting power. Fewer shots, certainly, but each individual round was capable of inflicting catastrophic damage. Neither philosophy was inherently superior to the other. They simply reflected profoundly different tactical doctrines and strategic priorities in aerial combat. Perhaps what most genuinely surprised Graf was the sheer level of comfort provided within the P-47's cockpit. The pilot's seat was remarkably well padded. The entire cockpit was heated with impressive effectiveness, and there was even a dedicated relief tube for extended missions, a seemingly minor detail that, in reality, proved immensely significant during the grueling 4-hour escort missions to Berlin and back. German fighters, by contrast, were fundamentally engineered for short-duration interceptions, rarely remaining airborne for more than 90 minutes at a time. The P-47, however, was unequivocally designed for marathon missions, featuring ergonomics that unmistakably prioritized pilot endurance and sustained operational capability over the strict adherence to minimum weight, a stark philosophical divergence. The control stick itself featured electric trim switches ingeniously built directly into the grip, a design choice that permitted the pilot to precisely adjust the aircraft's balance without the need to reach for separate, often cumbersome, trim wheels. While this might initially appear to be a trivial detail in the unforgiving chaos of aerial combat, maintaining one hand firmly on the throttle and the other consistently on the control stick at all times could literally spell the difference between survival and demise. The oxygen system presented yet another significant revelation. It utilized an advanced demand regulator that automatically adjusted the oxygen flow based on the aircraft's current altitude, a stark contrast to German systems, which necessitated manual adjustment by the pilot. Again, this was a seemingly minor refinement, but one that substantially reduced pilot workload during the intense and often disorienting environment of high-altitude combat. It became abundantly clear that American designers had meticulously considered every conceivable aspect of the pilot's operational experience, striving to make the aircraft as effortless to fly as humanly possible, thereby enabling the pilot to dedicate their full attention to the actual fighting rather than being distracted by the constant management of complex systems. Hermann Graf had not even started the engine yet, and already the Thunderbolt was profoundly challenging his deeply ingrained assumptions about the fundamental principles of fighter aircraft design. With a deep, resonant, and distinctly throaty bellow, the formidable R-2800 double Wasp engine roared to life, its sound profoundly different from the characteristic high-pitched scream of a Daimler-Benz inline engine. Graf meticulously allowed the powerful engine to warm up, precisely following the checklist that the diligent mechanics had painstakingly translated from captured American manuals. He watched intently as the cylinder head temperature gauges steadily climbed into their designated green arcs, indicating optimal operating conditions. The entire aircraft, even at idle, vibrated perceptibly with a sense of barely contained, immense power, a remarkable sensation given that he had not yet even begun to advance the throttle. When Hermann Graf finally disengaged the brakes and began to taxi the formidable aircraft toward the runway, the sheer weight of the P-47 became immediately and profoundly apparent. It did not dance lightly across the ground like the nimble Bf-109. Instead, it lumbered, requiring deliberate, heavy applications of the brakes to control its speed and aggressive, short bursts of throttle to coax it into motion from a complete standstill. The takeoff roll itself proved to be considerably longer than Graf had anticipated, even with the immense power of that massive engine. The Thunderbolt accelerated with a steady, rather than explosive, surge, its significant mass demanding more runway length than any other single-engine fighter he had ever piloted. At approximately 100 miles per hour, he gently eased back on the control stick, and the P-47 lifted off the tarmac smoothly, climbing away from Reckland with a remarkable stability that felt almost akin to flying a bomber. There was none of the inherent twitchiness characteristic of a Bf-109, nor any tendency to swing uncontrollably on takeoff, unlike the notoriously torquey FW-190. The Thunderbolt simply flew with an impressive solidity and predictable grace. However, once the P-47 reached altitude, the dynamic of flight completely transformed. Graf leveled off at a commanding 25,000 feet and meticulously began testing the aircraft's nuanced handling characteristics. He immediately noticed that the controls felt considerably heavier than those of German fighters. The ailerons, for instance, demanded genuine muscular effort to move at high speeds, and the elevator responded with a sensation akin to pushing through molasses, particularly when contrasted with the almost feather-light touch required for the Bf-109. Yet, within this perceived heaviness, there resided an undeniable precision. When Graf commanded a turn, the P-47 responded with exact fidelity to his input, then settled into the new attitude without any overcorrection or unsettling bobbling. It possessed a remarkable stability, almost to the point of feeling reluctant to engage in rapid maneuvers, but this very characteristic would prove invaluable as a rock-steady gun platform. German pilots often grappled with maintaining their aim during blistering high-speed attacks precisely because their fighters were so acutely sensitive to control inputs. The Thunderbolt's deliberately heavier controls, by contrast, promised to keep the gun sight firmly and steadily fixed on target, a crucial advantage in a dogfight. It was at this juncture that Graf pushed the nose of the mighty P-47 decisively downwards and fully opened the throttle, for this was the very maneuver from which the Thunderbolt's formidable reputation had largely originated, and the German pilots desperately needed to ascertain if the widespread stories of its prowess were indeed true. The airspeed indicator climbed with alarming rapidity, sweeping past 300 miles per hour, then 350, 400, and ultimately 450 miles per hour. Throughout this breathtaking acceleration, the aircraft remained absolutely rock-solid, exhibiting no discernible buffeting, nor any alarming tendency to tuck or pull itself inadvertently into an even steeper dive. even at a staggering 500 miles per hour, speeds that would typically induce severe control surface flutter and significant structural concerns in most German fighters. The P-47 still felt remarkably controllable and responsive. Graf then pulled back firmly on the stick to recover from the dive, and the Thunderbolt seamlessly converted its immense dive speed into a soaring, almost vertical climb that effortlessly carried him back up several thousand feet in mere seconds. This, then, was unequivocally the Thunderbolt's paramount killer advantage. In the fluid and perilous environment of aerial combat, a lightning-fast diving attack immediately followed by a steep zoom climb was widely considered the safest and most effective fighter tactic. The attacking pilot would plunge towards his target with enormous, almost uncontrollable speed, unleash a rapid, devastating burst of fire, and then utilize that immense kinetic energy to swiftly climb back to a position of altitude and safety before any enemy aircraft could mount a retaliatory strike. The P-47 possessed an unmatched ability to dive faster than any aircraft the Luftwaffe could deploy, and, crucially, it could sustain those extreme speeds for considerably longer periods. A Bf-109 pilot, attempting the perilous feat of following a diving Thunderbolt, would face an unavoidable dilemma. Either he would have to prudently break off the pursuit, or risk catastrophically exceeding his own aircraft's structural limits. Furthermore, even if a German pilot somehow managed to momentarily catch a P-47, the American pilot could simply push the throttle fully forward and extend away, effortlessly using the Thunderbolt's superior straight-line speed to decisively break contact and escape any further engagement. The evaluation of the P-47 Thunderbolt's flight characteristics began with an assessment of its ability to break away from an engagement using its superior speed. However, its turning capabilities presented a stark contrast. When Graf initiated a sharp turn at a moderate altitude, he immediately encountered the inherent limitations of the aircraft. The P-47 certainly maneuvered, but its turns were noticeably wide, resulting in a rapid depletion of kinetic energy during sustained aerial circling. In such a scenario, a German Messerschmitt Bf-109 or Focke-Wulf FW-190 could effortlessly outmaneuver the Thunderbolt, quickly gaining an advantageous firing position if a dogfight descended into a prolonged turning engagement. Yet, a crucial insight dawned upon Graf. It was highly improbable that American pilots operating these formidable machines would ever permit such a situation to unfold. Why would they? Equipped with unparalleled speed, exceptional altitude performance, and a remarkable zoom climb capability, P-47 pilots possessed the distinct advantage of dictating the parameters of any aerial confrontation. They held the strategic prerogative to select precisely when to engage in combat and, equally important, when to disengage, thereby compelling their German adversaries to contend on terms that favored the American aircraft. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Please write a comment below about where you are from and what you think about the video topic. The series of rigorous evaluation flights extended over several days, with a cadre of different pilots meticulously exploring every facet of the Thunderbolt's expansive performance envelope. A swift consensus emerged among them. While this aircraft did not conform to the conventional definition of a dogfighter, particularly in the European tradition, it was undeniably a profoundly effective combat platform when its inherent strengths were judiciously exploited. The extensive flight testing successfully elucidated many questions regarding its aerial performance, but it left the most perplexing enigma unresolved. How, precisely, did these aircraft manage to withstand damage that, by all logical accounts, ought to have been catastrophic? Luftwaffe pilots were certainly not succumbing to mere imagination. Vivid combat footage captured by gun cameras unequivocally depicted 20mm cannon shells striking P-47s with precision, generating unmistakable explosions upon impact. Despite these devastating blows, the American fighters astonishingly continued their flight. Instances were recorded where P-47s returned to their airfields bearing dozens of perforations, their control surfaces visibly shredded, and their engines significantly impaired, only to be made ready for flight again the very next day following diligent repairs. German intelligence urgently required an understanding of whether this remarkable resilience stemmed from sheer luck, superior engineering and construction, or some specific design characteristic that could potentially be countered through new tactics or weaponry. The dedicated team at Rechlin consequently resolved to adopt a direct and unequivocal approach. Their plan involved subjecting the captured P-47 to direct fire from their own arsenal, meticulously examining the precise consequences of each impact. This methodology was not without precedent. The Luftwaffe had previously conducted similar weapons effectiveness tests on captured enemy aircraft. Typically, these involve mounting the target aircraft on a static stand and firing at it from various angles, designed to simulate conditions encountered in actual combat. However, the forthcoming P-47 test was envisioned to be far more exhaustive and comprehensive. The team intended to target the aircraft's most critical systems: the powerful engine, the voluminous fuel tanks, the intricate control surfaces, and the vital cockpit area, meticulously documenting the exact threshold of damage the aircraft could endure before becoming utterly unflyable. The principal armament selected for this critical testing was the MG-151-20, the ubiquitous 20mm cannon that had become the standard weapon in the majority of Luftwaffe fighters by 1943. This potent weapon propelled a 115-gram high-explosive incendiary shell at an impressive velocity of approximately 720 meters per second. In the fierce crucible of combat, a solitary, well-aimed strike from an MG-151-20 possessed the capacity to obliterate critical components, sever essential control cables, or ignite highly flammable fuel tanks. Most seasoned German pilots generally regarded 3 to 5 solid hits from this weapon as entirely sufficient to bring down any Allied fighter aircraft. For instance, the formidable FW-190A8 typically carried 4 such cannons, endowing it with truly devastating firepower, though its ammunition supply was somewhat constrained, totaling roughly 250 rounds across all 4 weapons, which amounted to merely about 5 seconds of continuous, sustained fire. The meticulous arrangement of the testing environment demanded exceptionally careful planning from the German engineers. They positioned the P-47 precisely on the expansive Rechlin firing range, securely anchoring it to prevent any unintended movement, yet ensuring that all its vital systems remained fully accessible for comprehensive post-test inspection. The aircraft's fuel tanks were filled with genuine aviation fuel, a crucial detail designed to test the efficacy of its self-sealing technology under the most realistic conditions possible. The cockpit was extensively instrumented with sensitive pressure sensors and high-speed cameras, intended to meticulously record and document the precise events occurring when rounds inevitably traversed the pilot's immediate area. Furthermore, a lifelike dummy was even installed in the pilot's seat, strategically positioned directly behind the robust armor plate, to ascertain whether the aircraft's protective systems genuinely offered any practical defense. To accurately emulate the diverse attack angles encountered in genuine aerial combat, several MG-151-20 cannons were strategically mounted at various positions surrounding the aircraft. In real-world engagements, fighter aircraft seldom attack from perfectly perpendicular trajectories. The overwhelming majority of attacks originated from the rear quarter, often slightly from above or below, as the aggressor diligently sought to close into effective firing range while simultaneously endeavoring to evade any defensive fire. The planned test was designed to meticulously replicate these realistic combat angles. This involved firing at the engine from a shallow angle, precisely mimicking a typical pursuit attack, striking the wings from the side to rigorously assess the vulnerability of the fuel tanks, and targeting the tail section to observe with precision how the intricate control systems would react to battle damage. The careful selection of ammunition was also deemed of paramount importance. German 20mm rounds were produced in several distinct varieties, armor-piercing projectiles specifically designed for engaging heavily armored bombers, high-explosive incendiary rounds optimized for combat against agile fighter aircraft, and mixed belts that judiciously alternated between these different types. For the test, combat-loaded ammunition would be utilized, representing the exact same mixture that Luftwaffe pilots typically carried on their actual operational missions. This specific loadout included the formidable meningescus rounds, which were distinguished by their thin-walled construction and an unusually high concentration of explosive filler compared to conventional cannon ammunition. These particular rounds were notoriously devastatingly effective against aircraft, possessing the capability to inflict immense structural damage with just a single, well-placed hit. Observers from across the diverse technical branches of the Luftwaffe converged to witness this pivotal event. The undertaking was driven by objectives far more profound than mere scientific curiosity. Should the P-47 prove susceptible to specific attack methodologies, such intelligence would instantly become invaluable for operational planning. Conversely, if the aircraft demonstrated remarkable resistance, the Luftwaffe would then face the imperative to develop entirely new ammunition types or refine existing combat tactics. An additional, pressing concern revolved around resource allocation. Germany was already experiencing immense strain in its efforts to produce sufficient quantities of aircraft and ammunition to sustain operations on multiple active fronts. If the current arsenal of weapons proved ineffective against the robust American heavy fighters, the Reich simply could not afford the continued expenditure of precious ammunition on attacks that consistently failed to yield decisive results. With meticulous precision, the test crew loaded the formidable cannons, scrupulously verified that all measuring equipment was functioning flawlessly, and prepared to definitively answer the burning question of whether the P-47 Thunderbolt was truly as impervious as it appeared to be. The first cannon discharged with a sharp, resonant crack that reverberated across the vast expanse of the Reckland test range, propelling a 20mm shell directly into the P-47's engine cowling. The impact was instantaneous and dramatic. A vivid flash of orange erupted as the high-explosive round detonated with destructive force, immediately followed by the appearance of a clearly visible, jagged hole punched clean through the metal skin. The assembled observers meticulously documented the initial results and promptly prepared for the subsequent shot. This was not conceived as a mere single-bullet assessment. Their comprehensive plan was to subject the Thunderbolt to the relentless, sustained torrent of fire it might realistically encounter during an actual combat engagement, emptying multiple cannon magazines into its most critical areas to simulate a determined and skilled attack by an experienced enemy pilot. More rounds continued to slam into the engine section from a variety of different angles. Each successive impact generated a distinct and unique pattern of damage. Some projectiles cleanly pierced through the structure, leaving precise entry and exit holes, while others detonated violently inside various components, unleashing fragmentation damage that radiated outward from the point of impact. The massive R-2800 engine, despite its formidable construction, absorbed hit after relentless hit. Cylinders visibly cracked, cooling fins shattered into fragments, and substantial chunks of the cylinder head broke away. The accessory section, where vital generators and hydraulic pumps were mounted to the engine, sustained several direct hits. By any conventional standard of assessment, this engine should have been utterly destroyed, completely inoperable, and an absolute write-off. The German gunners then redirected their precise aim towards the wings, specifically targeting the aircraft's integral fuel tanks. This particular phase of the test was where catastrophic failure was most anticipated. Aviation fuel is inherently volatile, and the 20mm high-explosive incendiary rounds were meticulously engineered with the explicit purpose of igniting such fuel tanks. A single, well-placed hit on an unprotected tank would invariably transform an aircraft into a raging fireball. The Luftwaffe had witnessed countless Allied aircraft erupting into spectacular mid-air explosions following a fortunate cannon hit that located a vulnerable fuel tank. The P-47, however, carried multiple fuel tanks strategically located within its wings and fuselage, boasting a substantial total capacity exceeding 300 gallons. One decisive hit, it was widely believed, ought to suffice to incinerate this aircraft entirely. The very first 20mm round struck the left wing tank with pinpoint accuracy, dead center. The expectant observers braced themselves for an immediate explosion or, at the very least, a visible eruption of flames. Instead, to their profound astonishment, they merely witnessed fuel spraying from the entry and exit holes, creating a transient mist in the air, followed by an unsettling stillness. There was no fire, no explosion. The aviation fuel simply leaked out and began to pool harmlessly on the ground beneath the wing. The gunners, undeterred, fired again and again, punching multiple new holes through the wing tanks from various angles. Each successive impact resulted in more fuel leakage, but crucially, there was still no ignition. The self-sealing technology was unequivocally performing its function, but even more remarkably, the high-explosive rounds were evidently failing to create the critical fuel-air mixture necessary for combustion. It became apparent that the tanks were designed with sufficient internal structural integrity to prevent even explosive cannon shells from inflicting the catastrophic damage required to ignite the volatile fuel. Attention subsequently shifted to the critical cockpit area. German fighter aircraft typically featured only minimal armor protection, and a 20mm hit anywhere in the immediate vicinity of the pilot's position was almost invariably fatal. The P-47's robust armor plate, positioned directly behind the pilot's seat, was primarily designed to intercept rifle-caliber rounds and mitigating shell fragments. The crucial question arose: could it effectively withstand a direct impact from a 20mm cannon shell? The unequivocal answer was no. A direct, perpendicular hit on the armor plate would, without doubt, result in penetration. However, the comprehensive testing unveiled a more intriguing revelation. The armor was strategically positioned and meticulously angled in a manner that rendered a direct, perfectly perpendicular hit exceedingly improbable in a dynamic combat scenario. The vast majority of rounds struck at oblique angles, and even when they did manage to penetrate, the armor's inherent design effectively deflected them sufficiently, ensuring that the dummy occupying the pilot's seat remained relatively protected from devastating injury. The tail section then became the focus of an equally brutal and systematic assault. Control cables, vital hydraulic lines, and the fundamental structural components that rigidly secured the tail surfaces to the fuselage all sustained direct hits. The rudder was utterly shredded, its aerodynamic integrity compromised beyond recognition. The elevator, a critical control surface, was riddled with multiple holes punched clean through its structure. And the vertical stabilizer, a crucial component for directional stability, appeared as though it had been viciously attacked with a giant cheese grater, so extensive was its damage. This magnitude of destruction was precisely the kind that would, under normal circumstances, render most aircraft completely unflyable. Control surfaces, by their very nature, demand a smooth and intact profile to function with precision and efficacy. Any significant compromise to their integrity should undeniably impair the pilot's ability to exert proper control over the aircraft, a predicament that becomes especially perilous at high speeds where aerodynamic forces dramatically amplify every minute imperfection. The relentless scrutiny of close examination served to amplify every single imperfection, revealing the true extent of the aircraft's ordeal. After approximately 50 20mm rounds had been methodically discharged into various sections of the formidable P-47, the skilled gunners prudently ceased their barrage. A hazy veil of smoke, emanating from the spent propellant and several smoldering components, gracefully drifted across the expansive test range. Yet, conspicuously absent was any sign of a catastrophic explosion, no immense inferno, nothing remotely resembling the definitive destruction of a combat kill. The resilient P-47 remained steadfastly in position, undeniably battered and extensively perforated, but remarkably, its fundamental structure remained entirely intact. The true crucible of its endurance, however, awaited the post-firing inspection, during which astute engineers would meticulously scrutinize precisely what had withstood the onslaught and what had succumbed. The dedicated inspection team, armed with their clipboards, cameras, and an underlying current of professional disbelief, cautiously approached the bullet-riddled P-47. From a considerable distance, the aircraft presented a desolate sight, appearing as if it could never again ascend into the heavens. Yet, upon closer examination, the extent of the damage proved even more profound and pervasive than initial observations had intimated. The engine cowling, once a sleek protective shell, now resembled a coarse sieve, its surface marred by jagged apertures that starkly exposed the intricate cylinder banks beneath. The wings, too, bore unmistakable signs of trauma, with some perforations gaping wide enough to permit the insertion of a clenched fist. The fabric covering of the tail section, where it had not been entirely obliterated, hung in tattered remnants, rustling softly in the breeze. Nevertheless, as the engineers embarked upon their systematic and rigorous examination, they were repeatedly confronted by the same perplexing reality. Critical operational systems, though undeniably wounded, had not been utterly annihilated. Stay with us and watch the end of the video. We will be grateful for your like and subscription. The meticulous inspection of the engine yielded the first truly significant revelation. Indeed, numerous cylinders had sustained direct hits, and cooling fins were fractured, while various accessory components lay shattered. However, the colossal engine block itself, the massive, inherently robust crankcase that constituted the very core of the formidable R-2800, remained astonishingly intact. German engineers, with a dawning realization, comprehended that the sheer physical dimensions of the radial engine conferred an intrinsic layer of protection. With a total of 18 cylinders arranged in a dual-row configuration, the loss of even 2 or 3 cylinders still left a substantial complement of 15 fully functional. The engine, though it might operate with a pronounced roughness and experience a considerable diminution in power output, would nevertheless continue to function. A liquid-cooled inline engine, such as the DB605 found in a BF109, possessed no such inherent redundancy. Damage to any single cylinder in such a design typically precipitated a rapid loss of coolant, inevitably leading to catastrophic overheating and a complete seizure within a mere matter of minutes. Furthermore, and of paramount importance, the P-47's intricate oil system had exhibited an extraordinary resilience. While multiple oil lines had been undeniably severed, and the oil tank bore the scars of penetrations, the system was endowed with sufficient capacity and an ingenious redundancy. Consequently, even with significant leakage, an adequate volume of oil would persist to ensure the engine remained lubricated for the crucial minutes required to reach the sanctuary of friendly territory. In stark contrast, German fighters typically carried smaller oil reservoirs, often positioned in more vulnerable locations. A single 20 mm impact to the oil system of a Bf-109 was, in practical terms, a harbinger of certain engine failure and, ultimately, a death sentence for the aircraft. The scrutiny of the fuel tanks perhaps unveiled the most astonishing discovery. The self-sealing tanks were far from a simplistic rubber coating. They represented sophisticated, multi-layered engineering marvels. The outermost layer consisted of conventional aluminum, primarily serving to maintain the tank's structural integrity and shape. Encasing this was a layer of vulcanized rubber, followed by a layer of untreated rubber, which in turn surrounded the innermost layer responsible for containing the fuel itself. When a bullet or fragment of shrapnel traversed these layers, the fuel would interact with the untreated rubber, causing it to rapidly swell and expand, thereby physically sealing the perforation within mere seconds. German engineers had previously encountered self-sealing tanks in British aircraft, but the American implementation demonstrated a superior robustness, capable of effectively sealing larger apertures and withstanding multiple penetrations. The rigorous test had inflicted approximately a dozen 20 mm holes across various fuel tanks, and every single one had either fully sealed or was in the advanced stages of sealing. While an initial leakage of fuel had occurred, it had subsequently ceased or diminished to an imperceptible drip. Crucially, the tank's internal structure had prevented the kind of explosive fuel vaporization that commonly led to catastrophic fires. Internal baffles and, in some tanks, foam filling ensured that even high explosive rounds could not generate sufficient fuel mist to ignite. An Allied pilot might indeed lose 20 or 30 gallons of precious fuel from combat damage, but he would not, crucially, forfeit his life to a devastating conflagration. The examination of the control system damage recounted an equally illuminating narrative. Multiple control cables had been entirely severed, a type of damage that, under conventional circumstances, should have rendered the aircraft utterly uncontrollable. However, the P-47 ingeniously employed dual, and in some instances, triple redundant control runs. The ailerons, for example, were equipped with two distinct cable systems, routed through separate sections of the wing. Similarly, the elevator and rudder possessed both primary and backup control mechanisms. Even with several cables compromised, at least one functional control path invariably remained. While the controls might become noticeably stiffer or less responsive, demanding greater physical exertion from the pilot, they would nonetheless continue to operate. A damaged P-47, though potentially challenging to maneuver, would unequivocally remain flyable. Even the electrical system evinced a profound degree of thoughtful redundancy. It incorporated multiple generators, several independent battery systems, and strategically placed circuit breakers designed to isolate and contain damaged sections. In contrast, a Bf-109 suffering electrical damage would frequently experience a complete and simultaneous loss of all electrical power. The P-47, conversely, could sustain the loss of half its electrical system and still maintain power to its critical instruments and essential radios. The engineers meticulously documented every detail, recording precise measurements, capturing numerous photographs, and collecting material samples for subsequent in-depth analysis. Their preliminary conclusion was both inescapable and profoundly humbling. The Americans had conceived and constructed an aircraft that, from its very first rivet, was engineered with the explicit purpose of enduring combat damage. This was not merely a matter of fortuitous circumstance or the use of superior materials. Rather, it was a systematic design philosophy that unequivocally prioritized pilot survival and the potential for aircraft recovery above the minimization of weight or the maximization of performance metrics. The Germans, in their design ethos, had been constructing fighters primarily to excel in dogfights. The Americans, conversely, had been building fighters with the fundamental objective of bringing their invaluable pilots safely back home. The comprehensive technical report, compiled by the Reckland engineers, spanned dozens of pages, yet its fundamental findings could be distilled into a single, damning sentence. German fighter design philosophy had been fundamentally erroneous for the specific nature of the war they were currently prosecuting. The official document, predictably, did not articulate this conclusion with such stark bluntness. Military bureaucrats seldom did. However, the profound implications were unequivocally clear to anyone capable of discerning the subtext. The P-47 embodied a radically divergent approach to aerial combat, one that consciously accepted certain compromises in exchange for overwhelming advantages in pilot survivability and operational endurance. The meticulous armor analysis revealed a profound level of foresight regarding bullet trajectory and probability. American designers had not merely affixed steel plates haphazardly onto the airframe. Instead, they had diligently studied the most probable angles of enemy fire during typical combat engagements and strategically positioned armor accordingly. The robust seat-back armor provided crucial protection against the most prevalent attack angle, originating from behind and slightly above. The fortified windscreen armor safeguarded against head-on attacks and effectively deflected fragments resulting from engine hits. Even the thickness of the armor varied, judiciously calibrated based on the probability of threat. Critical areas received quarter-inch plating, while less vulnerable sections were afforded lighter protection. While the Germans also incorporated armor, it was typically minimal, positioned more as an afterthought than as an integral and foundational design element. The sophisticated self-sealing fuel tank technology utterly captivated the German chemists and engineers. They meticulously dissected sample sections and subjected the intricate rubber compounds to rigorous analysis under controlled laboratory conditions. The system's efficacy hinged upon a specific chemical reaction between aviation fuel and untreated rubber. Upon contact with the rubber layer, the fuel initiated a rapid and pronounced swelling. This rubber possessed the remarkable capacity to expand to several times its original volume, thereby creating a robust plug that effectively sealed holes up to approximately 12 millimeters in diameter. Larger perforations, while perhaps not sealing entirely, would still experience a significant restriction in fuel flow. The Germans possessed similar technology, but their implementation was demonstrably inferior. Their self-sealing tanks frequently failed after sustaining multiple hits, whereas the American tanks could endure numerous penetrations and continue to function effectively. The pervasive philosophy of redundancy permeated every single system on the aircraft, and this, perhaps, proved to be the most challenging concept for German engineers to fully assimilate. Redundancy inherently entailed additional weight, increased complexity, higher costs, and a greater maintenance burden. Within the German military-industrial system, already severely strained by the exigencies of a multi-front war, such apparent inefficiency seemed almost profligate. However, the American calculus was fundamentally different. The United States possessed an industrial capacity to spare, an abundance of raw materials, and a strategic philosophy that profoundly valued highly trained pilots as irreplaceable assets. Consequently, constructing a heavier, more expensive fighter that reliably brought pilots home was considered a far superior investment than building lighter, cheaper fighters that invariably resulted in higher pilot casualties. The report concluded with detailed calculations pertaining to combat effectiveness. While a Bf-109 might indeed boast superior maneuverability and a more advantageous power-to-weight ratio, if it possessed a 30% probability of being destroyed by damage that a P-47 would unequivocally survive, then the American aircraft was, in the final analysis, demonstrably more effective. Pilot training consumed months of intensive effort and incurred costs far exceeding that of any single aircraft. Experienced pilots became exponentially more valuable over time as they assiduously accumulated invaluable combat knowledge. The Americans clearly grasped this critical calculus. The Germans, too, understood this principle, but their industrial capacity simply could not sustain the implementation of the American solution. I am from your country/region. I found the video topic incredibly insightful, highlighting the profound differences in engineering philosophy between the Allied and Axis powers during World War II. The emphasis on pilot survivability in American design, contrasting with the German focus on pure performance, offers a compelling explanation for combat outcomes beyond simple statistics. It underscores the strategic value of human life and industrial capacity in warfare. One particular segment of the comprehensive report delved into a subject that would have been almost sacrilegious to address within official Luftwaffe channels: the intricate dynamics of pilot psychology and morale. The astute engineers meticulously observed that American aviators, imbued with the unwavering conviction that their formidable aircraft could absorb an astonishing degree of damage and still safely convey them home, were consequently inclined to press their offensive maneuvers with greater audacity and to disengage from combat situations with significantly less reluctance. In stark contrast, German pilots, operating inherently fragile fighter planes, would inevitably cultivate a heightened sense of caution, leading them to prematurely disengage from engagements and to more readily eschew unfavorable combat scenarios. This profound psychological disparity dramatically amplified the P-47's inherent material advantages. The aircraft, therefore, was not merely mechanically superior in its robust survivability, it actively fostered a crucial mental edge that rendered American pilots demonstrably more perilous adversaries. The exceptional manufacturing standards employed in the P-47's construction also elicited extensive and detailed commentary. The Thunderbolt was engineered according to rigorous production line specifications that German factories, by 1943, were simply incapable of emulating. Its riveting exhibited a remarkable uniformity and precision, while its welds consistently demonstrated impeccable quality. Furthermore, the interchangeability of components between individual aircraft presented a technological luxury that German maintenance crews, accustomed to the painstaking process of hand-fitting parts and improvising repairs, found almost beyond belief. This unparalleled manufacturing excellence meant that even combat-damaged aircraft could be rapidly restored to operational status using readily available, standardized parts. Conversely, German fighter repairs frequently necessitated bespoke fabrication for replacement components, a process that consumed invaluable time and highly skilled labor, both of which were becoming increasingly scarce resources. The Rechlin report culminated with a series of recommendations that were, paradoxically, both eminently practical in theory and utterly impossible to implement in practice. It proposed that the Luftwaffe ought to adopt redundant flight control systems, enhance its self-sealing fuel tank technology, substantially increase armor protection, and fundamentally redesign its fighter aircraft with survivability elevated to a primary, rather than a secondary, design consideration. However, the actual execution of these far-reaching recommendations would have mandated a wholesale retooling of factories, a complete redesign of aircraft from their foundational blueprints, and a significant reallocation of vital resources away from immediate wartime production. Germany, at that critical juncture, simply did not possess the requisite time, raw materials, or industrial capacity to emulate America's burgeoning example. Their only recourse was to meticulously document their findings and harbor a faint hope that incremental, gradual improvements might, at best, marginally narrow the ever-widening technological chasm. We hope you are finding this analysis insightful. Please stay with us and watch the end of the video. We would be incredibly grateful for your like and subscription. Also, please take a moment to write a comment about where you are from and what you think about the video topic. Your engagement means a lot to us. Upon its completion, the report was duly stamped, formally classified, and subsequently distributed to all pertinent technical offices, where it joined a burgeoning collection of hundreds of other intelligence documents that starkly chronicle the uncomfortable truth: Germany was systematically losing the technological and industrial dimensions of the conflict. The profound implications stemming from the Reckland findings reverberated through Luftwaffe tactical planning like a palpable shockwave propagating through water. For months prior, fighter commanders operating on the Western Front had harbored growing suspicions that their established combat methodologies were progressively proving less effective when pitted against American heavy fighters. However, mere conjecture and definitively documented proof were, of course, entirely different matters. Now, these commanders possessed irrefutable engineering data that unequivocally corroborated the persistent reports from their frontline pilots. Engaging P-47s using traditional aerial combat techniques was not merely an inefficient expenditure of precious ammunition, but, far more critically, a tragic waste of invaluable pilots' lives. The Luftwaffe was in dire need of novel combat methodologies, and that need was immediate and pressing. The initial tactical modification that had to be implemented was, perhaps, the most psychologically challenging for the German airmen. German aviators were issued explicit directives to eschew protracted engagements with P-47s whenever such avoidance was feasible. This instruction fundamentally contradicted every deeply ingrained instinct that had been meticulously drilled into fighter pilots throughout their training. Established air combat doctrine unequivocally emphasized aggressive action, relentlessly pressing attacks, and the decisive destruction of the enemy. Yet, the start data presented in the Reckland report graphically illustrated that a pilot flying a Bf-109 or an FW-190 could expend their entire ammunition load into a formidable Thunderbolt without achieving a definitive kill. Conversely, that very same Thunderbolt, even if visibly damaged, possessed the terrifying capability to effortlessly obliterate the German fighter with a solitary, precisely aimed burst from its formidable array of 8.50 caliber machine guns. The mathematical reality was brutally simple and unambiguous. Engaging in a direct exchange of fire with P-47s constituted an untenable and ultimately losing proposition. Consequently, German tactical documents began to place a pronounced emphasis on specific attack methods meticulously designed to maximize the probability of inflicting catastrophic damage. Pilots received instructions to aim exclusively for the cockpit, if at all possible, this being the solitary vulnerable area where a singular, well-placed hit could guarantee a kill, irrespective of the aircraft's inherent durability. This directive, however, proved considerably more straightforward to conceptualize than to execute effectively in the chaotic reality of aerial combat. The cockpit represented a diminutive target on a rapidly moving aircraft, and American pilots were rigorously trained to weave constantly an evasive maneuver that rendered precise aiming exceedingly difficult. Nevertheless, this approach was deemed superior to squandering precious ammunition on hits to the wings and fuselage, which the incredibly robust P-47 could readily absorb without critical failure. Another strategy that received strong advocacy was to initiate attacks from a directly head-on trajectory in swift, passing maneuvers. This particular tactic achieved a dual objective. It presented the German pilot with a simultaneous opportunity to strike both the cockpit and the engine, and it effectively neutralized the P-47's inherent advantage in defensive armament. The Thunderbolt's formidable guns were all meticulously mounted in its wings, meaning their cone of fire converged optimally at a specific range, typically approximated at 300 yards. At distances either closer or further than this optimal range, the concentration of the fire cone became significantly less dense. A head-on pass transpired with such breathtaking speed that both pilots possessed only a fleeting fraction of a second in which to fire, and the German aircraft's centrally mounted cannons enjoyed a marginal geometrical advantage in that split-second, high-speed interaction. Of course, engaging in head-on attacks was profoundly terrifying, immensely psychologically demanding, and unequivocally required nerves of steel. Closing at a combined speed exceeding 600 miles per hour, with both pilots hurtling directly towards each other, neither willing to be the first to break away, it stood as a supreme test of courage no less than piloting skill. Certain commanding officers championed the radical approach of simply disregarding the P-47s entirely, and instead concentrating all efforts on the heavy bombers they were tasked with escorting. This, after all, constituted the Luftwaffe's overarching strategic mission, the systematic destruction of the American heavy bombers that were relentlessly demolishing German industrial capacity. If the P-47s proved too resilient and difficult to efficiently destroy, then perhaps the more judicious tactic was to acknowledge their presence, employ superior numbers to draw them away from the vulnerable bomber formations, and then strike the B-17s and B-24s while their escorts were out of position. While this method yielded sporadic successes, American fighter tactics rapidly evolved to effectively counteract it. P-47 units subsequently began flying in sophisticated layered escort formations, with some fighter elements maintaining tight proximity to the bombers, while others conducted unconstrained hunting patrols at varying altitudes, poised to swiftly intercept any German adversaries that materialized. The profound psychological ramifications stemming from the P-47's remarkable durability extended far beyond mere tactical considerations. German pilot morale experienced a significant decline when they were forced to confront the demoralizing reality that they could execute every maneuver flawlessly, achieving a perfect attack position, delivering numerous precise hits, and witnessing their ammunition strike home, only to frequently observe the American fighter departing, perhaps emitting wisps of smoke, yet fundamentally operational. This fostered a pervasive sentiment of futility, a deep-seated conviction that the adversary possessed inherent technological superiorities that neither individual piloting skill nor sheer battlefield bravery could ultimately surmount. Such an outcome proved especially disheartening for veteran aviators, whose professional standing had been meticulously constructed upon their precision marksmanship and tactical acumen. After dedicating years to perfecting their aerial artistry, that profound mastery now appeared tragically insufficient when confronted with the formidable achievements of American engineering. Personnel within maintenance and logistics departments derived their own distinct inferences from the detailed Rechlin report. The consistent observation that P-47s were frequently returning to their airfields with battle damage that would have irrevocably incapacitated German fighter aircraft implied that American ground crews were investing substantial, and often enormous efforts, into repairing existing machines instead of solely focusing on producing new ones. This insight hinted at a potential, exploitable point of vulnerability within the expansive American logistical framework. The hypothesis emerged that if the Luftwaffe could inflict damage upon a greater number of P-47s than American repair facilities could realistically restore, they might effectively diminish the enemy's operational strength without necessarily securing outright aerial destructions. This realization consequently precipitated a nuanced alteration in mission conceptualization. Hence, Mission Triumph was occasionally reevaluated and redefined as rendering an enemy aircraft sufficiently damaged to be inoperative for several days, rather than solely as its destruction in flight. By the nascent months of 1944, the high command of the Luftwaffe had arrived at a profound and unsettling comprehension. They were contending with an adversary whose industrial ethos diverged fundamentally from their own, and this critical disparity was overtly manifesting in a level of combat efficacy that tactical adjustments alone could not adequately overcome. The exemplary performance of the P-47 Thunderbolt during its rigorous examination under fire at Reckland transcended its status as a mere intriguing detail within Luftwaffe intelligence dispatches. It signified a pivotal moment in the trajectory of military aviation, fundamentally reshaping the approach to the core query of aircraft design imperatives. The subsequent post-war era would unequivocally demonstrate that the critical insights gleaned from that extensively perforated aircraft profoundly informed the evolution of fighter aircraft on both factions of what would eventually crystallize into the Cold War schism. The overarching principle of engineering aircraft for paramount survivability, rather than solely for agile maneuverability, transitioned from a debated concept into established doctrine. American aeronautical engineers meticulously examined the P-47's exemplary combat history, and subsequently refined its underlying principles to an even greater degree. The Republic F-84 Thunderjet, conceived in the twilight years of the 1940s, unmistakably inherited the Thunderbolt's foundational design characteristics: formidable mass, high velocity, and an inherent capacity to withstand severe battle damage. This robust design philosophy permeated beyond the realm of pure fighters, extending into specialized attack aircraft, such as the iconic A-10 Thunderbolt II. Unveiled in the 1970s and remaining actively operational in the contemporary era, the A-10 essentially embodies the P-47's core concept extrapolated to its ultimate logical conclusion, featuring redundant flight control systems, a heavily armored cockpit, self-sealing fuel reservoirs, engines strategically positioned to offer mutual protection against ground-based ordnance, and the astonishing capability to return to base even with substantial portions of its airframe compromised. The very existence of this remarkable aircraft stands as a powerful testament to the P-47's irrefutable validation of the survivability concept. Soviet aircraft engineers diligently analyzed captured German intelligence assessments pertaining to Allied aerial platforms, including the pivotal Reckland observations. Subsequent post-war Soviet fighter designs conspicuously demonstrated a heightened prioritization of aviator safeguarding and systemic redundancy. This evolving design ethos was notably evident in aircraft such as the Su-25, the Soviet counterpart to the A-10, which integrated a substantial number of analogous survivability attributes. The numerous proxy engagements throughout the Cold War era, ranging from Korea to Vietnam and Afghanistan, furnish ceaseless substantiation that aircraft meticulously engineered to ensure the safe return of their pilots undeniably justified any associated weight compromises. Even the German High Command eventually assimilated this crucial lesson, though their realization arrived far too late to sway the ultimate outcome of the conflict. Subsequent German aircraft designs emerging in the latter stages of the war, such as the formidable Ta-152, began to incorporate heightened provisions for pilot protection and markedly improved fuel system resilience. Similarly, the revolutionary jet aircraft initiatives, particularly the groundbreaking Me-262, saw the integration of self-sealing fuel tanks and superior armored plating as intrinsic components of their standard specifications, a notable departure from their previous status as mere afterthoughts. Regrettably, by the period these significant enhancements were ready for deployment in operational aircraft, Germany found itself critically bereft of essential resources: aviation fuel, adequately trained aviators, and the necessary industrial infrastructure to make any meaningful impact. The once pioneering Luftwaffe, which had initially set the benchmark for innovative aerial combat strategies, was ultimately overwhelmed by adversaries who had not only mastered sophisticated tactical maneuvers, but also commanded an incomparably superior industrial production capability. The profound human cost directly attributable to these underlying engineering decisions became strikingly evident when one examined the comparative pilot loss rates. American fighter pilot casualty figures in the European theater, while certainly not negligible, were unequivocally and substantially lower than those sustained by German aviators, a disparity that became particularly pronounced in the war's final years. While a portion of this difference could be attributed to the sheer numerical superiority of Allied forces and their more rigorous training regimens, a significant and undeniable segment stemmed directly from the inherent survivability designed into their aircraft. American pilots frequently emerged relatively unscathed from aerial mishaps and battle-inflicted damage that would almost certainly have proven fatal for their German counterparts. To illustrate, a robust P-47 Thunderbolt could endure being riddled with scores of bullet holes and still manage to complete its arduous journey back across the English Channel. In stark contrast, a Messerschmitt Bf 109 suffering comparable damage would invariably compel its pilot to bail out over enemy territory, with capture representing the most optimistic possible outcome. Stay with us and watch the end of the video. We will be grateful for your like and subscription. Write a comment about where you are from and what you think about the video topic. The enduring legacy of this design philosophy extends far beyond its initial military applications, permeating into civilian sectors. Modern commercial aviation's profound commitment to redundancy, manifested through the meticulous inclusion of multiple, independent backup systems for every critical operational function, can trace its philosophical lineage directly to the very same engineering mindset that conceived the P-47. Iconic examples abound. The Boeing 747's distinctive four-engine configuration, the implementation of triple redundant hydraulic systems in today's sophisticated airliners, and the elaborate, multi-layered fire suppression systems, all collectively embody the fundamental lesson that ensuring the safe return of passengers and crew unequivocally justifies the integration of additional mass, increased structural complexity, and higher manufacturing expenses. The specific P-47 aircraft subjected to rigorous testing at the German Reckling facility likely did not survive the entirety of the war. Historical records indicate that the vast majority of captured enemy aircraft at that installation were either obliterated during intensive Allied bombing raids or systematically demolished by retreating German forces to prevent their reacquisition. Nevertheless, the profound influence of that particular aircraft persisted indelibly in the minds of every engineer and pilot who meticulously studied those revealing test results. They had been presented with irrefutable proof that an aerial platform could be conceived and constructed to withstand a degree of punishment previously considered insurmountable. And that undeniable proof fundamentally reshaped the prevailing thought processes regarding the architectural principles for future fighter aircraft development. Today, the imperative of military aircraft survivability stands as a primary design consideration, integrated from the very earliest conceptual stages of development, rather than being an incidental afterthought. While specific methodologies have undeniably evolved, encompassing groundbreaking advancements like stealth technology, sophisticated electronic countermeasures, and innovative advanced materials, the core philosophical tenet remains steadfast and unaltered. The most effective aircraft is ultimately the one capable of safely bringing its pilot home. The P-47 Thunderbolt, positioned within that German test range, stoically absorbing sustained 20mm cannon fire, and steadfastly refusing to succumb, demonstrated that profound principle in the most direct and unmistakable manner possible. German engineers had initially embarked on a mission to decipher the remarkable resilience of these American fighters. They indeed received their definitive answer, meticulously documented their findings, and in doing so, inadvertently helped to forge the foundational blueprint for every combat aircraft that followed. The test was initially conceived to expose weakness. Instead, it unveiled a transformative revolution in aviation design philosophy, a paradigm shift destined to outlast World War II, endure beyond the Cold War era, and continue profoundly influencing aircraft development well into the 21st century.